We are now starting our third unit, rational numbers. So for this unit, we're going to be focusing on adding, subtracting, multiplying, and dividing rational numbers. And you're probably wondering, what does this word rational mean? And that's what we're going to be looking at today in topic 1. A big part of this unit is going to be dealing with fractions though, so get ready for that. That's probably the trickiest part, but not in this topic so much. A little bit in this topic. So to start out with topic 1, what is a rational number? So let's just look back on what an integer is. And we've talked about what integers are quite a bit in class. They are just positive and negative numbers with no decimals. So any number you could think of, they could be positive or it can be negative as long as it doesn't have any numbers after the decimal point. So for instance, 1,000 would be an integer, 1 billion would be an integer, negative 100 would be an integer. And then we also looked at how to add and subtract integers. And number lines can help you with that. So remember, for instance, if we had 2 minus 5 is equal to blank, question mark, we would start at 2, and then remember, if you're subtracting, we move to the left on the number line. So we would subtract 5 from the 2. 1, 2, 3, 4, 5. And we will end up at negative 3. So 2 minus 5 would then be negative 3. So that's how you can use a number line to help you, or you can just plug it in your calculator and that will work as well. But now let's look at what rational numbers are, because this is kind of a new word that we're dealing with here. So rational numbers, they include integers, so that's what we just looked at up here. They also include fractions, and they also include decimals that terminate. So remember this word terminate, we talked about that. The terminator, he ends people. So terminate means that the decimal ends somewhere. If you get fired from your job, you're terminated. You get your job's over, it ends. So for instance, 2.5 or 6.154, those are both decimals that terminate. They don't go on forever. So all of those things are included in rational numbers. Now let's look at how we can write fractions as terminating or repeating. Let's fill in the blank here, decimals. So we can write fractions as terminating or repeating decimals by dividing the numerator by the denominator. So that's pretty easy, and we've looked at this in class as well. So for instance here, we have negative 3/4 or 3 over 4. So in your calculator, you would do 3 divided by 4, because we talked about how this little symbol there, the little line in a fraction, is divide. So 3 divided by 4, and if you put that in your calculator, you're going to get 0.75. And make sure you include that negative sign out front. It's chilling out front, so we'll just tack that on there. I'm actually going to write this in a different color. Let's do blue. So negative 0.75 would be our answer there. Same thing for this one, 1 over 4. So in your calculator, you would do 1 divided by 4. And if you do that, you should get 0.25. Easy peasy. This time it's positive. There's no negative sign over here, so we're just going to leave our answer as positive. And finally, 7 over 3. So if you put 7 divided by 3 in your calculator, which I'm going to do right now as well, 7 divided by 3, you're going to get a repeating decimal this time. It'll be 2.3, and the 3 will go on forever and ever and ever. But another way we can actually write a repeating decimal is you only write one of the numbers that's repeating. So the 3 is the thing that's repeating, and then you put this little line over it. And the little line means that it's repeating forever and ever after that. And then I'm going to also tack on that negative sign out front, because this is a negative number. So negative 2.3 repeating is how you would say that. Now, all mixed fractions can be written as improper fractions and vice versa. So if you might remember doing this in middle school, so let's just fill this in, improper. So we have mixed fractions and we have improper fractions. So mixed fractions is when it has this big number out front like these two do. And improper fractions is when the numerator is bigger than the denominator. So 25 here is bigger than 7, so that's improper. 62 is bigger than 5, so that's improper. So let's just get some practice writing these, converting them from mixed to improper. So how we would do that is we would take the number on the bottom and we're going to multiply it by the number on the side. So we would do 6 times 3, and then we would add the 5 to it on the top. So if I were to write this out in the front, we're going to do 6 times 3 plus 5. And that's how it works every single time you're converting from mixed to improper. So 6 times 3, if we dealt with that, we would get 18. And then we're going to add 5 to it. So our final answer over here is going to be 23, because 18 plus 5 is 23. And then the number on the bottom, the numerator, it stays the same. So this 6 here would stay the same. So if we were to write 3 and 5/6 as an improper fraction, we would get 23 over 6. Let's try the same thing. We're going to skip over to this one here because it's the exact same thing. So this time we are going to do 4 times 5 plus 1. So if we were to do 4 times 5, we get 20, and then plus 1 gives us 21. So our answer is going to be 21 over, and the denominator stays the same, 4. So 5 and 1/4 is equal to 21 over 4. Okay, so now that we converted from mixed to improper, we can also convert them the opposite way. So let's start out with these improper ones here. You want to see how many times can the bottom number, so for instance in this case 7, go into 25. So in my head I'm going to count by 7s. So 7, 14, 21, 14, 21, 28. Now 28's over 25. So really 7 only goes into 25 3 whole times, right? 7, 14, 21. So 3 is our magic number for the big number out front, 3. Okay, but now we need to think about that fraction next to it. So when I put 7 into 25 3 times, I ended up at 21. So we need to think how many more numbers are remaining to get to that 25 from 21. So 21, then it would be 22, 23, 24, 25. So that's 4. So in our fraction, it's going to be 4/7 remaining on the side. So the denominator stays the same, 7, like it did here, and then 4 on the top because that's how much was remaining to get to the 25. Another way you can kind of do this is you can put it in your calculator and you can just do 25 divided by 7 in your calculator. And if you were to do that, I'm going to do it right here, 25 divided by 7, you get 3.5714, and it's like some decimal that goes on forever. So this 3 here that we get, this whole number 3, is telling us that 7 goes into 25 3 whole times, which is what we found out the last method we did it. And then this remainder here is this fraction. Okay, if we were to put 4 divided by 7 in our calculator, you actually get this exact same decimal number that's on the end here. Okay, and if that doesn't make any sense to you, try to follow that first method I did. So let's do another one here together. I'm just going to erase all this to make it look a little nicer. Now, another thing I want to show you is that you can check your answer with this. Okay, if we converted from improper to mixed, let's just convert back to improper to make sure that it's okay. So how we would do that is we would do 7 times 3 plus 4. Now 7 times 3, that gives us 21, plus another 4, would give us 25, and boom, would you look at that, we have the numerator that we want. And then remember, the denominator would stay the same, which is the 7. So then we know our answer is correct. So let's try this one over here. So this time we have negative 62 over 5. The negative makes it look a little more scary, but you know what? That thing's just chilling out front, so we're going to ignore it for now. We're just going to look at the 62 over 5. So we need to think, how many times can we get 5 to go into 62 without going over 62? So if I count by 5s, and I'm just going to use tally marks here to show you, we would have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And we're not going to go to 65 because that would be over 62. So if you count the tally marks here, we have 12 of them total. So that means the big number out front is 12. 5 goes into 62 12 whole times. But now we need to think, that only brought us to 60. How many more do we have remaining to get to 62? Well, 60 plus 2 would give us 62. So the number on the top here would be 2, and the denominator stays the same all the time. So 12 and 2/5 would be our answer, but we're missing one little thing. Don't forget about that negative sign floating out front. So our final answer would actually be negative 12 and 2/5. Okay, and you can even try putting this in your calculator, and if you were to do that, you would do 62 divided by 5, and you would get 12.4 in your calculator. So this little 12 here tells us 5 goes into 62 12 whole times, which is why it matches that number out front. And if you do 12 times 5, it'll only bring us to 60. So then we know we need 2 more to get to 62. And remember, you can always check your answer with these. So we could go 5 times 12, which would give us 60, plus 2 would give us 62. So now we know we have the correct answer. Awesome. So let's move on here. All integers can be written as a fraction with a denominator of, let's fill in this blank, 1. Okay, and we talked about this quite a lot in class, so this will go really fast. So for instance, negative 13 can be written as negative 13 over 1. 2 can be written as 2 over 1. Nice and simple. Any number can be written like that with a denominator of 1. We just don't bother writing that denominator ever. So for the next example here, we need to write 3 rational numbers between each pair of numbers using a number line. So the number line is just going to help us kind of organize our thoughts a bit. So I'm just going to make a little number line here, put 0 here. Now 2.5, let's just write here, I'll do 1, 2, 3, 4, 1, 2, 3, 4, and then I'll do negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4. So let's just begin by putting these two numbers on the number line. So 2.5, that's pretty easy. It would be right in between 2 and 3, and that's positive. So here's 2.5. That's a decimal point there. And then negative 3.67. So that'll be between negative 3 and negative 4, and it's almost like halfway. It's just a little more than halfway, right? Because halfway would be negative 3.5. So this is negative 3.6. So that would be approximately there. So we need to write 3 rational numbers in between those ones. Okay, and remember, rational numbers, if we scroll back up here, a rational number can be integers, fractions, and decimals that terminate. So we can really pick any number in between those two. So there are a billion different answers you could give me here. But a couple answers I'm going to just plot down. How about we do negative 2? That's in between those two numbers. So is 0. It's a rational number. And how about, let's pick a decimal. How about 1.25? Sure. Okay, so those 3 are 3 rational numbers in between 2.5 and negative 3.67. Moving on to the next one. This one's a little bit more tricky. Okay, and I would almost consider this one a level 2 question because it can be a little tricky to think about. So if we are making our number line here, I'm not going to do the number line like I did in the last one because these two numbers are really close together. Okay, I'll have 0 here. Now, I'm going to just put -1 here and I'm going to put a +1 here. But really, we're only going to be focusing in this little area here because if you look at both of our numbers, they're both negative. Okay, we have -0.43 and we have -0.44. So let's place those down. They're like right beside each other, right? Because -0.5 would be right in the middle. So -0.43 and 44 are going to be like here and here. They're like right beside each other. Okay. Now, which one's going to be closer to 0? Well, if we think about it, -0.43, that's not as negative as 0.44. 0.44, we're getting deeper into the negative section. So this one over here would be -0.43. And this one over here would be -0.44. So now we have to think, how do we place numbers in between those two numbers? Well, the way we do that is we just add a decimal point, right? Because if we're thinking about it, if we have two numbers, let's say 2 and 3, how would we place two numbers in between there? Well, we just add a decimal point. For instance, 2.1 is in between those two. 2.2 is in between those two numbers. So we're going to do the exact same thing here. We're going to add a decimal point to the end of this number. So our answers in this case could be something like -0.431, because that's going to be in between those two numbers there. We could also have -0.435. That's in between those two. And we could also have -0.43. Let's do 2. Okay, so there's 3 numbers. They're rational because they're decimals that terminate. The decimals don't go on forever. And they're in between those two decimal points. That one is a little bit trickier. Now this last one, now we're in fractions. But you know what I say? Whenever you get a fraction like this and we're dealing with number lines, let's just convert them into decimals. And we know how to do that. In our calculator, we would just do the numerator divided by the denominator. So this one would be 1 divided by 4. So if we converted that to a decimal, it would be -0.25. And this one would be 1 divided by 2. So that would give us 0.5. If we put that in our calculator. So now let's plot those on our little number line here. I'm going to zoom in this number line a little bit again. Okay, so we have -0.25. So that is going to be approximately there. So here's our -1/4. And over here we have 0.5. So that's right in the middle. Oh, here, let me put a little 0 here. 1/2. So now we just need 3 numbers in between those two there. So for me, that's pretty easy. I'm going to stick to decimal numbers because I like dealing with those. So 0's right in between there. That's an easy one. How about right here? That would be 1/4, or in other words, 0.25. That's in between those two. And how about, let's do a -1 in here. That could be like -0.1. Okay, so you really got to get used to working with these decimal numbers here and knowing where they fall on a number line. Here's another example. Order these numbers from least to greatest and place them on the number line. So here's a little more practice. Okay, so 0.35. So that isn't quite 1. And that's not quite 1/2. So I would say that's approximately here. 0.35. 2.5, that's nice and easy. That's right in the middle here. 2.5. -0.6. Well, it's almost -1/2, so it would almost be here. Just a little bit over, though. It's a little bit more negative, so that's -0.6. 1.7, well, we have 1 right here, and then 0.7 is a little more than half, so I'd say 1.7 is here. Negative 3.2, so here's negative 3, and then we have to go a little more negative, so to the 0.2 section there. So negative 3.2, and finally negative 0.6 repeated, so that's like 0.6666666. Oh, would you look at that? We already have negative 0.6 on here. Well, this is going to be even more negative. Look, we have more numbers. It'll be more negative than 0.6. So I'm going to change the color here just so it's easier for us to see. But that's actually going to be right next to it, a little more negative. So this would be negative 0.6 repeated right beside it. Okay, so if we were to order these numbers from least to greatest, it would be negative 3.2, then negative 0.6 repeated, negative 0.6, 0.35, 1.7, and 2.5. Okay, now let's try it again, but this time with fractions. So I highly suggest converting these fractions to decimals. It makes your life a lot easier, but it is a little more work. So for the first one, negative 3 over 8, so I'm going to put 3 divided by 8 in my calculator, and I get 0.375. And make sure that's negative. And then we have 5/9, so I'm going to put 5 divided by 9, and I get 0.5 repeated. Then we have negative 10 over 4, so I'm going to put 10 divided by 4 is 2.5, and don't forget that negative sign, so negative 2.5. Then we have 1 and 1/4, negative 1 and 1/4, so that's going to be negative 1 point, and then if I do 1 divided by 4 on my calculator, we get 2.5. Okay, so all I did in my calculator for this one was I put that part in it. That gave me 0.25, and then the 1 goes out front there, and the negative sign too. 7/10, if I put that in my calculator, I get 0.7. And then 8/3, or 8 over 3, if I put that in my calculator, I get 2.6 repeated. Okay, so those aren't in order yet from least to greatest. How about we put them in order? We would have the most negative number would be negative 2.5, because that would land us right here, negative 2.5. Okay, then if we're moving up from there, I would say that this one's the next most negative, so negative 1.25, so negative 1 and then 1/4, negative 1.25. Okay, and then we would have, here's our other negative number, negative 0.375. Ooh, that's going to be close to 0, but in the negatives, so approximately there, negative 0.375. Okay, now we're moving into the positives. So I would say that 0.5 repeating would come next. That would be approximately 0.5, but just a little bit over. So 0.5 repeating. I won't be too picky about the number line stuff. It's kind of tricky to put them on perfectly. Okay, then we have 0.7, which would come right after 0.5, approximately there, 0.7. And finally, 2.6 repeated. So we have 2.6, that's almost 2.5, a little bit over. Just like that. So there we go, we're done that one there. Okay, and finally, for each rational number, write 2 fractions that represent the same number. So the way we can do this is we just multiply the numerator and the denominator by any number, and it'll give us what we call an equivalent fraction. Okay, so for the first one, I'm going to rewrite this down. Negative 4 over 5. Okay, and how about we just multiply the top and bottom by 2? It's nice and easy. Times by 2, times by 2. So our answer is going to be negative 8, because 4 times 2 is 8, and 5 times 2 is 10. So negative 8 over 10 is the exact same fraction as negative 4 over 5. They're equivalent. So here's one of our answers. And again, you could just do the exact same thing, but instead of multiplying by 2, we could multiply by, but we multiply by 10. That's nice. Multiply by 10. So that is going to give us negative 40 over negative, sorry, not negative 50, negative 40 over positive 50. So that is also an equivalent fraction. They're the same number. Okay, so how about for here, let's just do, first one we're going to times them both by 2. So 3 times 2 is 6. Negative 4 times 2 would be negative 8. So that would be one of our answers there. And for that one, I just times it both by 2. Okay, and let's do, how about we times by 5 this time on the top and the bottom. So that would equal 3 times 5 is 15. Negative 4 times 5 is negative 20, and we're done there. And then for the last one, we're going to do the exact same thing. Sorry, I'm just filling this in here. For the last one, we're going to do the exact same thing. Now remember, when we have a negative sign that's in the middle, we can actually just plop it on the top or the bottom number. It doesn't matter. So I'm just going to put it on the top number. So we would have negative 12 over 7, negative 12 over 7. Okay, so I like timesing by 2. That's nice and easy. And then let's times by 3 on the next one. Okay, so one equivalent would be negative 12 times 2 would be negative 24. And 7 times 2 is 14. And negative 12 times 3 would be negative 36. And 7 times 3 is 7, 14, 21. So negative 36 over 21 would be an answer there. So that was quite a lot of notes. Get those filled in. And then we're going to try these practice problems here on the next page.